All right, we're on question number 4. Question number 4, this is actually a throwback question from last semester. Which way does the parabola open? If you all can remember this, the parabola opening up or down depends on the value of a. So in this case, since a is equal to a positive number, then we know this parabola opens up. The next one, in this case, a is a negative number, so this parabola opens down. And then the last one, this a value, -1/8, a is also a negative number. Let me go ahead and circle these so you can verify. If you didn't learn this last semester, you can remember. There is our a value. Why do we call it an a value? Because the vertex form of a parabola looks like this. Y equals a times x minus h squared plus k. So our a value is right there in the front. So then this one, of course, also opens down. Please don't get fooled by a parabola opening left or right. That is something you will see next year. But in this year, we only deal with parabolas that open up or down. Let's take a look at question number 5. Write a standard equation of a circle with a center at 8, 0 and a radius of 8 inches. So if you look at this class, first thing you want to recognize is that the center gives us our h and our k value. The radius has to be squared in order for us to actually write the equation in standard form. So since the radius is 8, that means r squared is equal to 8 squared, and that is 64. Just to remind us what this equation looks like, you saw it in your vocabulary, but I'll write it again. You should be writing this down just so you get this in your head. Standard form of a circle looks like this. Y minus k squared equals r squared. If you have that on your paper or that in your head, then you know the only values we need to write standard form is the value of h, the value of k, and the value of r squared. So for this question, letter A, we can write our standard form for a circle is x minus 8 squared plus y squared equals 64. Let's take a look at where we got these. The h value is always going to be the opposite sign because the equation has minus h in it. That means it's going to flip the sign. Since our k value is 0, we don't have to write the k value. We just can write y squared, and there's our r squared is 64. Let's do another one now so we can see this. Here we've got h, here we've got k, and here we've got r. Since r is 5, then I know that r squared is equal to 5 squared, which is 25. We have to get r squared to write it in standard form. So here is our final form. X plus 3 squared plus y minus 4 squared equals 25. The 3 is positive because our h value is negative, the sign is opposite, and our k value is positive 4, so it shows up as the opposite sign in our equation. Last one, same process. We've got an h value of 7 and a k value of 5. This is a little unusual. Since r is a square root of 10, that means r squared is equal to the square root of 10 squared. And you learned last semester that square root and square are opposite math operations. They cancel each other out, just like division and multiplication and subtraction and addition. That means we're left with r squared is equal to 10. That just becomes 10. So our final equation is going to be x minus 7 squared plus y minus 5 squared equals 10. All right, question number 6. What is the radius of the circle with a center at 4, -2 and a point on the circle at 2, 3. Now, sometimes the equation or the question is going to give you a graph. If you can get the graph, I'm going to tell you, you get to use Pythagorean theorem. So the center is going to be at 1, 2, 3, 4, negative 1, 2. There is our center. And then a point on the circle, that means that point is touching the circumference of the circle. That's going to be at positive 2, positive 3. There's our point on the circle. Well, if we know those 2 points, then we know the distance between those 2 points is actually the radius. And we can find that radius by using the Pythagorean theorem. So I'm going to go ahead and do that now. Pythagorean theorem says if I can create a right triangle, then this orange line becomes the hypotenuse, and that's our C value. I can use the A value and the B value, our 2 legs of our triangle, to find the C value, or the hypotenuse. This leg is 2 units long. If you look right here, 1, 2. This leg is 1, 2, 3, 4, 5 units long. So now we're going to go ahead and use Pythagorean theorem. A squared plus B squared equals C squared. This C is going to be our radius. All right, A squared. I could pick either one of these, 5 or 2. Let's pick 5. There's our first leg. B is 2. That's our second leg. And C is going to be our radius. Now, if you want to just change that to R right now, just to say, hey, I know that's going to be my radius, you can do that. 5 squared is 25. 2 squared is 4. That's going to be R squared. 25 plus 4 is 29. 29 equals R squared. Well, they want us to find the radius. So I'm going to have to square root both sides. That means that if I square root the right side, that just changes to R. I'm going to square root the left side. I flipped them around just to make them look a little bit easier to understand. That means the radius is the square root of 29. That's an acceptable answer. But if I'm going to ask you to convert that to a decimal, then you're going to plug that into your calculator. Let's move that over. Let's plug that into our calculator. The square root of 29. And that equals 5.385. If I'm going to round that to 1 decimal, the 8 means I'm going to bump the 3 up to 4. So 5.4, approximately 5.4 units. Now, let's just look at something logical here, for those of you who are actually spending the time listening to the video. Clearly, the hypotenuse has to be longer than the longest leg. You would never have a hypotenuse of a right triangle that's equal to 5 or 2 or anything below 5. It couldn't be that case. Otherwise, you couldn't complete the triangle. This diagonal line from P to C has to be longer than 5. So if you get a number that's 4.8 or 3.2, clearly you've made a logical mistake. So always look at your final radius. If you're using Pythagorean theorem, it better be longer than the longest leg. It has to be logically. All right, now letter B is a little bit different. They didn't give us a graph. So now we're going to use the distance formula. So to use the distance formula, we still have a center and we still have a point on the circle. That means if I can figure out the distance from the center to a point on the circle, that's my definition of radius. I'm going to label this x sub 1, y sub 1. I'm going to label this x sub 2, y sub 2. And let's go ahead and use our distance formula. I'll write it for you just to remind us what it is. The distance formula is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And that whole thing is square rooted. All right, let's go ahead and plug in our values now. So I've got distance between those 2 points is equal to the square root of x sub 2 is negative 1. Now be careful because the minus sign is part of the equation. That's minus, and then x sub 1 is 5. And then we've got plus. Hold on while I stop that beeper. Means I got to finish up this video. Let's take a look. Y sub 2 is 4 minus, that's in our equation, and then y sub 1 is 2. And then that's going to be squared. All right? Let's go ahead and figure out what that equals. That's the square root of negative 1 minus 5 is negative 6 squared. 4 minus 2 is 2. That's 2 squared. Let's go ahead and put equal right here and keep on going. That's the square root of negative 6 squared is 36. Everything squared turns positive. 2 squared is 4. That means our distance between those 2 points is the square root of 40. The square root of 40. And we can go ahead and put that on our calculator if you are asked to do that and get the approximate value. If you do square root of 40, you're going to get approximately 6.3 units. So on the test, you're going to need to know how to use the Pythagorean theorem to find distance between a center and a radius, and if you're not given a graph, how to use the distance formula to find the distance between 2 points or the radius and a point on the circle.